Hello and welcome to a second edition of Stepping into the Code. Today we're going to talk about the universal project folder structure that is used in all of my projects. It'll give some idea as to how the different projects are organized and help you understand if you're interested in making changes to the code. You will know exactly where to go for everything, and you'll just be able to look at the files and sort of understand where things are. I'm going to talk about some design goals for doing things this way, and then we're just going to go straight into some examples using different levels of complexity. The first one is going to be what I call libraries. Then we're going to look at components, and then we're going to look at full-scale apps. And this might seem like a lot of new information because I think most people don't talk about this kind of thing, but try to maybe see how try to see the similarities between each of these different examples, because fundamentally there is like a method to this. It is kind of all just the same thing, and we're just looking at it from different viewpoints. Just 3 points on the design. In terms of the modular folder structure, this is something I like to call the folder is the cosmos. Like, each folder is about one thing, and everything that pertains to that one thing is in the folder. So if you want to understand where to go to edit something, it's probably very nearby. You shouldn't have to look through and like the entire project and navigate complex directory hierarchy to understand where to make a change. Like, everything is sort of self-contained. The second thing is that we're trying to decouple the logic of how the app works and what it does from the folder structure. And just as an example, there are some systems where maybe you're making a website and you have like /about, as like your about page. And so what that means is in your actual folder structure of the code, you have to have an about folder. And the fact that the folder is called about is going to be linked to the URL or something. We tried to avoid doing that ever because the goal here is to separate the logic of how the application works from the directory structure. I'll point to an example of that when I come to it. And yeah, the third thing about the design is that we're using the same logic across all projects. So if you understand one project, you understand all of them. That gives us a lot of leverage because we don't have to like get into the project and light candles, and it doesn't have to be such an event because you already kind of know where everything is, and every time you touch a project you're dealing with the same structure. So it becomes very simple to make changes. So that's just a little bit about the design. I don't want to like theoreticize too much. Like, I want to just show a lot of examples, and I think this video might get a bit long, so I'm going to try and go just as fast as I can and just show this thing from different perspectives. So what we're going to start with is what I call libraries, which are essentially collections of functions, or you can even say a list of functions. Okay, we're going to go to the string library, which I use quite often. And I'm going to try not to even open up the files here because this is really just about file names and understanding things from the directory itself. It's about seeing how much information you can get just by the file name. So here's the OLSK string, or old school string library, or I'll just say the string library. And there's effectively 3 files in here. There's this gitignore thing, which is very standard. It's in every project. It just ignores files from the version control system, so we're not really going to pay attention to that. Let's start with the package.json, right? Package is the thing that enables this folder to be considered as an NPM package, and we use that for our dependencies so that we can share code and reuse it between multiple projects. We have a main.js file. Main is a special word because it means that's where you start. What is this thing about? Like, that's what it is, right? So this is the string library, and that's the main file. In that main file, you're going to find all the definitions for the functions that are all those string functions, basically. And in this case, it's main.js because this is a JavaScript library, but as we'll see later, it could be something else, main.something else. But this is an important idea that like main is basically like what the thing is, and everything else in the folder pertains to that main thing. So package.json, main.js, and main-tests.js. These are the tests for the main file. So you have functions alpha, bravo, Charlie in main, and then in main tests, you have a series of 3 test suites. Each of them corresponds to one of those functions. And that's it. That's basically a library. It's like a bunch of functions, the tests that go along with those functions, and a package.json file. Most libraries are organized this way. So if I go into my libraries folder here with all of the different ones that I'm using, I can just kind of go through it randomly. Like here's OLSK beacon, and we have a package.json, we have a main file, and we have main-tests. It's the same structure that we just showed here. OLSK bundle, again, pretty much the same thing. Package.json, main.js, main-tests. Okay, but we also have something new here, which is package-bin. Here, it starts with package, so we intuit that it has to do with package.json. And in fact, this is it does have to do with how this thing works as an npm package, because bin is some word that n uses for like commands. So it means that this package has some commands that you can run when you install it. And what's the name of that command? It's olsk bundle, olsk-bundle. So just as an example here, again, I look at this folder with the files that are in it, and I get some sense of what is involved here, right? I understand from just by looking at the files that this is an npm module, and it's got main.js, main-test.js, so it's probably like a JavaScript library with a bunch of functions. And then it's got this package.bin thing. Oh, okay, so that means there's also a special command that I can run with this. Without opening the file and getting into the specifics of what it's doing, like you understand there's a command here. Going to the next one, OLSK cache, again, same thing. You have a package.json, because it's an npm library. You have main.js, main test, etc., etc. Most of the libraries are fairly similar in this way. There are some libraries in my collection that are very complex, like OLSK fund, for example. It's like a whole lot of stuff going on. I still consider this to be a library in the sense that it's just a collection of functions, but there are some interfacey things too, but I'm not going to explain this here because I think if you look at the next section, like you'll be able to understand this. But anyway, so libraries are fairly straightforward. They're just lists of functions, and they have a very small amount of files. I am going to show one slightly more complex example of a library, which is the zero data wrap library. And this is something, yikes. This is a library, which, as we can see here in the files, we got our main and we got our main tests. It's huge. Like the main file here is like 1,000 lines long. The tests for this thing are like there's 1,700 lines in this file. But fundamentally, it's the same concept of like, this is a library is a collection of functions. There's this main file with the functions, and then there's like the tests for that main file. So same structure, we can see the package.json here, so we know this works as an npm package. There's a readme here, which is just a markdown document. So readme, package, main tests. Those we've all seen before. There's something here called mocha-start.js. Mocha is how we run all of our tests. It means that we're going to run something before all of the tests start. The other things here, we can see there's some more test files. So in addition to main-tests, there's also main integrate remote storage-tests, main integrate fission-tests, main integrate custom tests. So again, this is a library that you can use to integrate with the remote storage protocol or the fission protocol with one API. And so we have some general tests, as well as some specific to remote storage tests, as well as some specific to fission tests, as well as this other thing called custom. Those could be named anything really, but there's not that much significance to the names. But you can see from what's going on here that, like, again, I'm just looking at the files, I'm not even opening them. This is an npm package, that's a JavaScript library, and we have some special stuff we do before tests, and we have some particular integrations that we're testing in separate files so that it's more organized, and there's a README. So just an idea of like how much information can I get just by looking at the files, right? And so that's basically libraries. let's take it up a notch in complexity, and we're going to go to components. In the previous video I did about running my projects on your machine, there is a description of system A and system B. They're organized the same way, but maybe the files are going to be different. So I'm going to do examples of system A components as well as system B components. And why are we calling this component as opposed to library? Again, library is just like a list of functions. Components are interface components. So it has to do with interface, UI. It's not just like abstract code, right? It's something that you see, you touch, and so that has some implications for what kind of files we're going to see. Okay, let's start with OLSK landing. So here's a component, and let's look at what kind of files we have in here. So we have a package.json, which again, it means it's a node module, an npm module. We can reuse this easily using the npm system. We have a main file, but it's not .js, it's .ejs. Because this is essentially, the main thing here is not like a bunch of JavaScript, it's actually a bunch of HTML. Quickly looking at it to open it up, you can see there's some HTML, and EJS is referring to like a templating language that's based on JavaScript, so we have some, we're just sort of spitting out some variables basically. So that's the main thing, that's what it's about this interface, and we have interface tests. So the name is a bit different. Dash tests is referring to logic test. UI test something is referring to interface tests. So again, quickly just to look at the file, like it's testing that there's a bunch of elements there, and then it's testing that we set some variable and then it binds it to the right elements. Most of the components are going to have something like this, but they will differ a bit more. There's more of a spectrum in terms of components, right? Libraries are very straightforward, a bunch of functions. Components are like, they can be a lot of different things. So obviously I'm not going to be able to go through them as easily, but I'll try and give some important landmark examples. Anyway, package.json, a main file, which is some HTML thing, and some UI tests. We also have this thing called controller.js, which better to explain this later, but for now, or at least until I really explain what it is, just try to understand that it's just for the purposes of testing. It has nothing to do with the actual component itself. You don't need controller.js to use the component, but in order to test the component, we're using my special magical minimalist framework, and the controller.js is part of that. But I'm not going to explain controller.js now. I'm going to do that in the app examples. So quickly moving on to app feature list, which is another component that's slightly more complex. App feature list, you can see there's a bit more stuff going on here, but it's still fundamentally system A component, right? We have our package.json. Okay, it's an npm module. The main file is an EJS file. So, okay, this is one of those node templating things. It's a component that uses the Node.js templating system or the EJS templating system. And I can also recognize the UI tests. So there are these different UI tests for this component. I also see a bunch of I18N files or internationalization files. And so I know that there's going to be some localized strings in this component. And we have our controller.js, which again, in the context of components, it's fairly superficial. It's just for the purposes of testing. We also have this thing called stub_view.ejs. This is something that's not always necessary. Often when we're testing system A modules, we can just use the main file directly. But in some cases, we have to do some extra stuff to just kind of coat the main file, and in that case we use a stub view. So it's sort of like wrapping it in a nice little container or something. But again, just for the purposes of testing. So in terms of the actual module, it's just a bunch of HTML, and it's got some tests, and it's got some internationalization, right? So that's basically like a system A component. Now we're going to look at a system B component, which is going to involve Svelte and compiling and building and stuff like that. And the example we're going to use is OLSK placeholder. So again, how much can we understand just by looking at the names of the files without opening anything? I can see from package.json that this is an npm module. There's a main file, which is a svelte thing that needs to be built. I can see there's internationalization here. I can see there's UI tests or interface tests. I can see that the stub view and the controller are here. So again, those are like specific to testing. There's a new thing here called rollup start. This is a very old component. So at the start, like I didn't know how to just like not have that file. So I think nowadays I don't have that file at all, but you will see rollup start in the app. I'll explain it at that point. And the next example we're going to go to is olsk install. So a little more going on here, but again, how much can we understand just from the files? So package.json, this is an npm module. The main file is a svelte file, so we're going to have to do some compiling or building when we run this, when we test this. Again, rollup start is superficial. Rollup-config is sort of necessary, but I'm going to explain that when we get to the app. And you can see we got our UI tests here, we got internationalization, we got the controller and the stub view thing specific to testing. Here we have something called UI logic and UI logic tests. So if you remember in the libraries, we had a main.js and main tests. That's because the main thing in the library is like a list of functions and then the test for those functions. In the case of a component, the main thing is not a list of functions. The main thing is an interface thing. So it's like HTML. But sometimes we do have like a list of functions that we use, or let's call it a library. We do have a list of like this library of functions that we use, which are specific to this component. So call this whatever you want. I just like to call it UI logic because it sort of groups it with the other UI stuff. And you understand that here's the logic, the list of functions, and then the logic tests are the test for those functions. So again, just by looking at the files, I have this picture of what's going on and where everything is. And I don't even really need to open it. I think that's all for components. And now we're going to talk about apps. Apps are going to be more complicated than a single directory, but they are fundamentally a collection of libraries and components. So everything is like it's still abiding by this idea of like the folder is the cosmos. Everything in a folder is pertaining to what that folder is about. Let's look at the main folder here. What do we see and what can we understand without having to open any files? So package.json, this is an npm package. You're probably not going to use like an entire single page app, JavaScript based app inside of your project, but we're using the npm system to handle dependencies. Okay, that's package.json. We see package-post install here, which should tell us that it has something to do with the package. And in fact, package post install is what runs after you install all of the npm dependencies. So it's going to do things like hotfix certain third-party modules so that I don't have to wait for a pull request. So I'm just literally like overwriting code from somebody's GitHub repository locally. And then I'm also copying certain modules into the public folder of the app. For certain apps that have like a website, we're going to have like a public folder. So package post install, and we got a Mocha start again. That means that we're going to do some stuff before we start testing to make testing easier and more clean in terms of how it's expressed. License.md, that's just a license file. README, again, that's just a markdown document. Maybe look at rollup-config here. So again, this is an app, and we're using system A and system B. System B is using rollup and svelte and compiling and building and all of those things. So we have a rollup config right at the beginning, which sort of configures the whole project in terms of its rollup. And there's actually not a lot of configuration happening because most of the configuration is happening in a different package. But here is where we connect the environment variables to the JavaScript. I didn't explain that. The apps usually are going to have an env sample file. Again, these are sample values for the environment variables that are needed for the app to build and function. So why do we do this kind of thing in a JavaScript app? For example, I have 2 demo videos for Hyperdraft in here. So if I wanted to change the video, I could either like dig through the code and find where it is and change it and make a commit into the thing and then sync and push that, or I could just change the variable for that. Right, I could just change the URL here. I don't have to update my code, I don't have to make a commit or anything. So I'm making extensive use of this by extracting certain constants and variables out into this env file. And this is a sample file. The one that I actually use is here. So when you install one of these projects and get it working on your machine, the setup command will copy this information over to the env. And those things from the env are given to the JavaScript via this rollup-config thing. So here you can see some of the same values that are defined here. And that's because the rollup thing happens in the context of Node, and the JavaScript stuff happens in the context of window, and there isn't really a way to talk between each other. So this is the way we do it. We start in Node, we tell Node to pass environments to the building process, and then it goes from there. Way too much information for right now. Don't worry about trying to understand anything I just said there. But just that's kind of what it means. Anyway, so that's just sort of the first directory there. The rest of it is going to look more like all of the modules that you've seen before. I try to avoid magic and conventions, but I do have this one thing that hopefully will be customizable at some point. OS app is essentially like the app. That's where it is. If you want to know where it is, it's in that folder. And so inside the app folder, we have a bunch of other subfolders inside. And effectively, each of these things is going to be either a library or a component, or at least that's how I look at it. Looking inside this app folder, you might notice how a bunch of these directories here have a prefix. So there's the open prefix, there's the sub prefix, there's the tech prefix. These things are just my own personal preference. They could actually be called anything. You don't even need the prefix actually. It could just be, instead of open guide, it could be guide. Instead of open vitrine, it could be vitrine. But I like to have these things group in a certain way. So that's the only reason for that. There's no other magic. And in terms of what they actually mean to me, if you're curious, open means that this is some kind of publicly facing thing. Because not every folder or module in the app is going to be public facing. So this is representing something that's going to be public facing. Maybe like vitrine is like the front page of the website. Guide is like a markdown document that's sort of like a documentation page. And write, in the case of Hyperdraft, is the actual app. And then we have sub, which is like submodule. Again, there's different ways to like organize submodules. Sometimes I do it this way, sometimes I do it in a different way, but that's what sub means. And tech is like stuff that basically machines interact with. So the manifest, for example, tech manifest means the manifest file used to install your app on a home screen. Robots is something that's used by search engines to index your site in their listings. SW, or like service worker, is something your browser uses to make sure your app works offline. So I just group all these things together by calling them tech. But you can call these things anything you want. These are just personal preferences. And then there's underscore shared. The underscore doesn't mean anything. It's just by personal preference. I like that it's at the top, that it sort of looks different. Because this folder is just stuff that's used between those other folders. So shared, right? And inside it, we got like, you can see here's like a library, and here's another library, main tests, and yeah, these are all just libraries. Oh, this one is a component, yeah, main.ejs. But just even quickly looking at this, like you can see just by the files that are there, you understand what it is, how to interact with it. There's a lot of information in these file names. It sort of gives a shape to each module. And then we also have this thing here called underscore external. When I said public directory, this is what I was talking about. And it's not automatically public because it's called external or something. I've explicitly named this. But the thing I want to point out here is the double underscore. For example, this is a project where we're going to like build something. We're going to take a bunch of Svelte files, compile it together, spit out some JavaScript. that thing, some people call that like distribution or like dist, stuff that is generated from your actual code, your project. Um, I don't believe in like committing these things into the version control system, so I always want to hide them. But I don't want to say, oh, ignore this folder, ignore that folder, blah, blah, blah. So I have a convention defined in the git ignore, yeah, defined in the git ignore where underscore underscore blah, blah, blah is going to be ignored. So you might see underscore underscore compiled or underscore underscore external in this case. And these things are effectively excluded from Git. That's all that means. But it's a useful convention because you don't have to like define specific folders and you're probably not going to have any conflict with that. Okay, so moving on, I just want to show how these are libraries or components. So here's the guide module, and here there's no main file, there's a UI view file. This could have been called main, but we got a bunch of tests, we have some internationalization, we have a controller. Oh, the controller, yeah. This is another example of decoupling the file structure from how the app works. If we open up controller, we see that there's a URL defined, /guide. It's actually just a property of this route object. We don't have like a /guide folder in our project directory. We just have a controller that says that's where you accessed it from the browser. If I change that string, the URL to be accessed also changes. This is good, for example, in the vitrine controller. You can see it's a slash, so it's the root path. And you can see I've also defined in that controller file some language codes, English, French, Spanish, Portuguese. And we use those language codes defined in the controller in the interface tests, in these localization tests for the interface. And without going too deep into this, you can see here how I'm saying go to the controller and get the first route, and for each of the language codes of that route, we're going to run a suite of tests, and we're going to go to wherever that this route is located. In this case, it's the root of the site, and we're going to go to the corresponding language URL for that thing, and then we're going to check that each element that uses localization is using the correct localization string. Do that for each language that it supports, right? So this is an example of how the controller, it's a fairly simple thing, but it's very integral to other things as well. Let's swim up for some air here. Looking at the vitrine, for example, there's no main file here, but there's a UI view file. Again, maybe I could just call that an EJS file, main.ejs file. There's UI tests, there's UI style, which is just what I like to call CSS. You can call it anything you want. There's the internationalization stuff. I have a submodules folder here, which defines another module, which is, as you can see, a component because it's got main.ejs, UI tests, and internationalization. So all of this information you can get without opening the files, like just by looking at the directory. You have some idea of how it's organized and some idea of maybe even how it works. It might be worth also comparing with other apps. I'm not going to make a big comparison here, but for example, Joybox, Hyperdrive was like my first or second or third, let's say second app. Joybox is the most recent one, but it's got the same structure, right? This is what the initial directory looks like. Package, post install, Mocha, readme, rollup-config, environment sample. We go into the app folder and we can see shared, guide, vitrine. In this case, we have play instead of write because that's what that it's particular to that domain. We have some submodules. We have some text stuff, the same text stuff that we had before. In the shared folder, we have a bunch of libraries and one module. We have this common thing that's used. But you can see how I've changed like to a completely different app, and it's using the same folder structure that allows us to approach with the same mindset every time, and so we don't have to like get into a different mode with each app because it's all organized the same way. Think about also how often can you keep a project up to date without getting overloaded. It's too common in the open source world that people they make their projects and then they can't keep it up to date because they don't have the mental energy. Like they may even have the time and space, but just it's so heavy to get into the project because it's been a while or because they don't remember how it's organized. So um, I sort of take this as a badge of honor that like the 90 repositories that I have, like most of them have been updated in the last 6 months in some way. I mean, insignificant or significant, but I think it's useful to be prolific in that sense and to just be able to make changes and not have it be stressful. And the idea of like step-by-step continuous improvement that I think everybody in the technology world really strives towards. Like for me, this kind of organization really enables that. So yeah, probably this might not be for every single case, but I find that for me it really helps me scale. I've been able to touch a lot of different projects in a shorter period of time. And I don't feel super stressed out about that. But more importantly, you're using the same logic across all of these different projects, which means that if you understand one of them, you understand them all. Thanks for watching this super long video. Hope it's useful to you. If you have any feedback, please let me know on the forum or on social media, and hope to see you in the next one. Ciao.